I'm just going to let you know that as to how we gauge the reliability and validity of the construct, and then what are the various tests. So for the reliability, we have to see the two aspects. The first is internal consistency reliability and the item reliability. So here I must remind you that whenever you are writing a research paper or whether it's a PhD thesis, these are the minimum requirements which you have to report. Frankly speaking, this is my experience that even you miss one among them, there'll be a big problem for you, that reviewers must be asking from you that why you're missing. So at least if you're publishing an impact factor journal, so definitely these are the minimum checklists which you have to add in your research paper in order to ensure the reliability and the validity of your construct. So first, reliability. In the reliability, it's an internal consistency reliability, number one, and then is the item reliability. Internal consistency reliability, again the same thing, which is about the all of divide the people in the same way. And item reliability is the reliability of the individual statements, the understanding about the individual statement of any question. So these are the two aspects, two things which needs to be ensured for reliability. Now, internal consistency reliability is used for gauging that. We have a two tests statisticians have given us. One is we call the Cronbach alpha, the CB alpha, and the other one is the composite reliability or the CR values. I'll be just explaining with you that threshold values of that. And for the item reliability, we rely upon the factor loadings, that what could be the loading of item. So this is for the reliability, and for the validity, we have two aspects of the validity. One is the convergent validity and the other one is the discriminant validity. Convergent validity means that the extent to which all of the items of a construct are converging together in order to represent a particular construct. So for example, if I have 5 items of a construct, what is their convergence, what is their combined strength? So it's like 5 fingers of a hand. So how these 5 fingers are coming together in order to make a punch. So this is a convergence validity, that convergence of all of the items to represent the main phenomenon. And the discriminant validity is the individuality of each item. That, for example, if we are asking the 5 questions or 10 questions, each of the question is unique and contributing value to the major concept. It's not a duplication of any of the other items. So this is the discriminant validity. Now the both convergent validity is also checked at the item level, means the items are different from each other, and the same is also checked at the construct level. For example, it happens that we are taking 2 same constructs and the constructs are similar, and we do not need to take the both constructs. I have seen, I was reviewing one of the research paper in which they took their 2 parameters of the performance. One, there was a measure of the performance based on the productivity, and again that was an adopted questionnaire. The other was again there was an overall performance measure. So then one was labeled as the performance, the other was labeled as a productivity. But once I saw their correlations, and once I saw that how these 2 dependent variables are correlated with each other, so I could find that the both constructs are the same. So there was no need to have a 2 constructs. So one construct was in fact a subset of the other construct. So in that case, there was no discrimination, means no individuality between 2 constructs. So it was a high, that convergence. So in that case, I recommended them to have at least one. Remove that one and have the one. So putting together, convergent validity and the discriminant validity are the 2 opponent ends, different sides of the same coin, and both of them need to be tested. For construct level, convergent validity is tested through average variance extracted, And at individual level, it is tested through the inter-items correlation. Likewise, discriminant validity was about the reliability and the validity. So I told you that from the next slide that this is the graphical representation of what I was talking about, the reliability and validity. And you know that this it's the same thing we have put in the graphical interface where the internal consistency reliability is being it's being gauged by the Cronbach alpha, and composite reliability and item reliability is being gauged by the factor loadings. So what are the threshold values for that? So for the CB alpha, we have the threshold value that is 0.70. Uh, and although a number of statisticians in the literature, they allow it to be even, we can have to 0.65 or 0.6, but most of the statisticians and even the management science researchers do not recommend any value of CB alpha less than 0.7. The basic argument behind that this claim is that CB alpha is also not a very robust measure, and if we are relaxing its value, we may not end up with having good measurement of internal consistency. So I'll just recommend you that we can have CB alpha value of 0.7 or more. If it's less than that, definitely we have to, that recheck that whether there's some issue with our construct or whatever. Okay, then there is a composite reliability. This value, ideal threshold value is 0.7, but we can relax up to 0, even if it's or till 0.60, it's fine. We can move on with it. Okay, factor loading. This is a bit, that most typical thing that what could be the ideal value of factor loading and to what extent it could be relaxed. A lot of time we just see in the paper that the factor loadings are even less than 0.70, but they are there in the construct. So what are the bases and what would be the minimum value? Most of the people, they put the factor values minimum bar at 0.5. Most of the researchers I'm talking about, but here and some of the other colleagues, they have just put the factor loadings as the minimum value of the 0.40. Now, what are the various, what you call it, what are the areas to retain an item if its factor loading is less than 0.70? So, you know that factor loading is directly contribute to the average variance extracted of a construct, AVE. So in fact, AVE is the sum of the square of the factor loading of a construct. So if our factor loading is less than 0.70, but our AVE value is greater than 0.5. Again, I repeat that if our factor loading is less than 0.70, maybe 0.5, it may be 0.6, but its AVE, the AVE of the construct is greater than 0.5. So in that case, we retain that particular item, right? And even so, the here has given the threshold that even if your factor loading is less than 0.70, but it's greater than 0.4, but the construct's average variance extracted value or the AVE value is 0.5 or more, so we can retain the construct. But if the construct's value is AVE value is less than 0.50 and our factor loading value is also less than 0.70, so we'll keep on removing all such items which are lower than the 0.70 in order till the time that our AVE value does not become 0.5 or more. So that whether to retain an item which has a factor loading less than 0.70, the decision depends upon value of AVE, average variance extracted. Again, I repeat that whether to retain an item or not, which has a factor loading less than 0.70 and greater than 0.40, that the decision depends upon the value of AVE. If the AVE value is 0.5, you can retain that item. If the AVE value is less than 0.5, obviously we will not be retaining that item. This slide I'll be discussing also later on, but I just come till here. So this is again a very brief summary. to me, you can have this checklist with you always once you're writing your research paper or once you're doing your PhD thesis, that for the reliability, there are the two: internal consistency and item reliability. You need the three statistical tests: CB alpha, composite reliability, or the CR value, and factor loading value. So once we'll be running the smart PLS for the reliability, we have to fetch the results of these three statistical tests for each item. So for each construct, sorry. So for example, if we have a one independent variable, one dependent, and one mediator. So once we'll be running the smart PLS, we have to find out the CB alpha for all of the three variables. We have to find out the composite reliability for all three variables, and we have to find out the factor loadings of every item of our all three variables. So these information needs to be extracted from the PLS smart in order to check the reliability. Then there's a validity, the same representation, the discriminant and convergent validity. Discriminant is being further gauged by the two things. The construct level is being gauged by the formal Likert criteria. I'll be explaining that what formal Likert criteria and what the HTMT is. At item level is of the cross-loading. Again, we'll be discussing in the next slide, and convergent validity on the basis of AVE, average variance extracted. Now let's discuss one by one that what do we mean by the convergent validity and discriminant and these values, and how do we measure. In fact, the convergent validity is gauged by the value of average variance extracted, which should be 0.5 or more. This average variance extracted is the sum of the square of average of the sum of the square of all of the factor loadings. The point to learn is not its formula. The point to learn is that the average variance extracted is being computed on the basis of the factor loadings. And if your factor loading is 0.706 for each of your items, your AVE would be exactly 0.50, right? So if for example, if I have 5 items and every item has a factor loading of 0.70 on aggregate, so my AVE would be 0.5. It means that if the average of my factor loading is 0.70, my AVE value would be 0.50. So that's why you know that if one item has a value of 0.80, the other has 0.60, so the average is 0.70. So that's why we do not remove that item which has a factor loading even less than 0.70. So average variance extracted, and this 0.5 variance is showing that at least 50% of the 50% variance in the construct is being explained by all of the items together. So that's what we call it AV. So AV value, if it's greater than or equal to 0.50, our construct has convergent validity, and this has to be done for every construct. Coming to the discriminant validity, okay, one more thing, that convergent validity at item level, how to check it. So it is simply inter-item correlation, and that should be inter-item correlation should between 0.20 to 0.85. The value of inter-item correlation is between 0.20 to 0.85. We have the convergent items. If it's greater than 0.85, it is a problem of the multicollinearity that again we'll discuss. Okay, discriminant validity at item level, we check through the cross-loading. Now, what is cross-loading? Cross-loading is loading the construct of an item on the other construct. For example, I have two constructs. One is the construct of human capital. The other is the construct of innovation performance, or the innovation. There are the 5 items of innovation and 5 items of human capital. Cross-loading is that I am loading the 5 items of human capital on the innovation construct and the 5 items of innovation on the human capital construct. So this is the cross-loading. Ideally, obviously, the cross-loading should be lower than the actual loading. For example, if there are the 5 items of the human capital, they are being loaded on the human capital, so their factor loading should be higher as compared to the cross-loading. So the items of human capital should load higher at human capital, and they should have a lesser cross loading, means that if we are loading on the other constructs. So the formula is that the factor loading on the respective construct should be higher as compared to the cross loading. So that's for the item levels. At the construct levels, there are two criteria. One is the Fornell-Larkin criteria, and the other one is the HTMT criteria. Fornell-Larkin criteria is very simple, that we take the square root of the AVE, average variance extracted, and then we compare that square root with the inter-construct correlation. Okay, now what is the basic rationale behind this? Once we take the square root of the AVE, the square root of the AVE is showing correlation of a construct with its items. How much a construct is related with its items, this is being shown by the square root of the AVE. Now how much a construct is linked with the other construct, this is being shown by the inter-item correlations. So obviously the relationship of a construct with its item should be higher as compared to the inter-construct correlation. So the same are the parameters of the Fornell-Larkin criteria, that the square rooted values of AVE should be higher than the inter-construct correlation. So this is the Fornell-Larkin criteria for the construct level. And the other is which could be used, that's the HTMT. It's a simply the HTMT value should be less than 0.90 for each construct to be acceptable, or to have the discriminant validity or the loadings. Okay, and this is again the parameter of validity. It's in a one graph, that discriminant validity, convergent. Discriminant has two levels, construct level and item level. And for discriminant, square root of the AVE should be greater than the inter-constructs correlation. And then for the item level, factor loading should be greater than the cross loading. And convergent validity should be equal to AVE should be equal to or greater than 0.50. A brief recap that what we have discussed is, I discussed that PLS SCM is something which is combining the measurement model and the structural model, is combining the CFA and regression analysis to become PLS SCM. And the PLS SCM is estimated in two steps. Step number one is ascertaining the measurement model, and then step number two is the structural model or the path analysis, right? So in the measurement model, we have to first see the reliability and validity. Reliability, as I mentioned, that it is gauged through the two important parameters. One is the internal consistency reliability and the item reliability. Internal consistency reliability is gauged through the two tests, rollback alpha 0.70 and composite reliability 0, which is again 0.70. So I just about to inform you that this CR, the CB alpha is the lower bound value of the CR. So CB alpha means they're the two values of the reliability of the test. So CB alpha is the lower value, and the composite reliability, that could be the other end, so higher and the lower end. But nevertheless, if we are comparing composite reliability and CB alpha, so if composite reliability value is greater than 0.70, and even CB Cronbach alpha is less than 0.70, but fairly greater than 0.6, it is acceptable. We can move on. Item reliability, I told you that factor loading's ideal value is 0.7, but even if it is up to 0.4 and our average variance extracted value is greater than 0.5, it is acceptable. For the validities I told you that we have to see the discriminant validity of the construct, convergent validity of the construct. Discriminant validity is gauged by the Fornell-Larkin criteria. The Fornell-Larkin criteria means we are comparing the square rooted average variance extracted values, means square root of the AVE with the inter-construct correlations. And the criteria is that the square root of the AVE should be greater than inter-construct correlations. And at the item level, we go for the cross loadings, means we are loading the items of the one construct on the rest of the constructs in order to see the loadings on the rest of the constructs, which must be lower than the loading on the original construct. And for the convergent validity, we have the value of average variance extracted, which is the average of the sum of the square of the factor loading. So obviously it stems from the factor loading. At the end, this is the validities. Again, these are the third criteria in order to ascertain the discriminant and convergent validity. Okay, so again, as I told you that those three results need to be fetched from the PLS. These three results again also to be taken from the smart PLS in order to ensure the discriminant and convergent validity. These are in fact for AVE, HTMT, cross loadings, and values. So these are the three values which needs to be extracted. Okay, now the point is that how to present these results. What is the way in which we present these results into the research papers, or even we present these results in the thesis. So this is one of the way. It could be many formats, but this is one of the recommended format to present our results of the reliability and validity in the format. So this is the table number 1. Here will come your construct at this construct, and then these are your constructs. Then this item 1, item 2, primarily this is the coding of your questions. For example, if you have asked 3 questions and there's the statements basically. So item 1, C1 is the code of that first statement. Item 2 is the code of the second statement. Item 3, so these are the statements of your codes of your statement. Then here is your loadings, which we call it the outer loading, or this is called the factor loading of these items. Then this is AVE value, average variance extracted, which must be, so this loading can be up to 0.40 subject to this AVE value, which should be greater than 0.50. And then here comes your CR value, composite reliability, which should again be greater than 0.70, but it is acceptable to be at 0.60. Then there is a value of CB alpha, so which should be around at 0.70. So these are the 4 values: loading, factor loadings, AVE, CR, and CB alpha, which are presented combinedly in one table. And very interesting thing which you have to report, that what were the items which you removed. For example, sometimes it happens that we have removed the items which had a factor loading lower than for example, 0.40. So all those items which we will be removing from a construct need to be reported at the bottom of this table. So here, for example, items removed. The papers item, those 0.50 were item 4, item 5, or whatever those items codes were. Those codes need to be written here in order to inform to the reader that what were the certain items which were removed due to the lower factor loading. Okay, number 1. Number 2, you could see that this is A, and this is here explanation of A, that all the items loading 0.5 indicated. Okay, so now there are the two, as I earlier told you, that 2 criteria, that one is of the Holland. Holland is saying, that's a study of 1999, that we should have a loading 0.5 or more. But recent study of here, they have mentioned that even the item loading is 0.40 or greater, it's okay. So, but truth be told, I'll just suggest you that in the research papers, factor loading less than 0.50 is not encouraged. So to me, I'll suggest you that you just keep the factor loading minimum value of 0.50 or more. So whatever is less than that, if it is even 0.45 or 0.46, it can be removed by looking into your question. Okay. Then it is the brief explanation of AVE. And so this one in the bottom, you can see that these are the criteria which have been written, that their threshold values, CR threshold value should be 0.70, AVE threshold, and their references. So even this could be copy pasted as it is, except for the all items removed. This obviously these would be your own items which you'll be removing. So this could be the way we'll be presenting our results. Let me tell you that Smart PLS will not be giving you results in this format. Smart PLS would be giving you a result in an Excel sheet, but we have to fetch those results from the different Excel sheets of the Smart PLS, and then we have to summarize those results in this particular format. Okay, so these are the results of the reliability test, and convergent validity. Now this is the way we can present the results of the discriminant validity. So this is our the good thing is that formulaic criteria is given itself. It's computed in the same way in the PLS smart PLS result. So you just need to copy and paste and present it. So here this diagonal values are the square rooted values of AVE, and these are the inter-construct correlations. This CU are Y1, Y2, Y3. These are the inter-construct correlations which are so these diagonal values should be greater than this inter-construct correlations in order to have the formulaic criteria. And the HTMD value is also it is available in the smart PLS in the same format, and it should be less than 0.90. So simply we have to copy from the smart PLS and paste on the Word file to report these results. So essentially, when we present the results of the measurement model, these three tables are important. Whether you're writing for the Academy of Management or you're writing for any local journal or any international journal, this is the standard reporting criteria for presenting the results of the smart PLS. And I'm just to share with you, we have published a lot of research papers in very high impact factor journals by reporting the same criteria. So this criteria is something that which is already trial and tested. This format, you have to simply get your results put in here, and that's it. Then you have to explain these results, and we'll move forward. Once we'll be doing smart PLS, obviously we'll be explaining these results, and what is the interpretation of it, how to write the interpretation of these results. Okay, so this is till now what we have discussed is the first component of the first step of the PLS SCM, that is the reliability and validity of the measurement model and the reporting of results. If you have any question in it, please do ask the question. And if you don't have, then I'll be moving toward the structural model. So I'll wait for the 30 seconds. Maybe if you have something you can think of, and then we'll move forward.
Professor, I have actually not related to this, but on the formative model, how do we actually define a formative model or reflective? Because most of them are reflective, but yeah, how do we define this formative? What are the criteria, any test? You said QPA test to be done.
Yeah, for the formative model, first, a model is a formative or reflective. That primarily it depends upon the theory. It originates from the theory of that particular concept or the idea, that whether the constructs is being formed by the various items or those items are the reflection. This comes from the theory. But sometimes it happens that, for example, we have a state of commotion. The theory, we cannot clearly find out that a construct is reflective or formative, right? So there could be a situation. So then PLS Smart has given us a test which is called CTA, Confirmatory Tetrad Analysis, that if you are unsure about a construct, that whether it should be a formative construct or it should be a CF it should be reflective construct. So what we do is we model that construct as a formative construct, and then we run that confirmatory tetrad analysis, that is CTA, and based upon the results of the CTA, we can decide that whether this construct is formative or not, right? So if we are unsure about any of the construct, and we cannot find theoretical support, or we cannot find any way to decide that whether it's a reflective or formative, so we can take help of the smart PLS and can apply the CTA, confirmatory tetrad analysis, that we'll be discussing maybe today or in tomorrow's session, and that will help us to understand that whether it is reflective or formative construct.
This CTA test applicable for a second order construct, formative second order construct?
CTA is applicable for any, obviously it is applicable, you can do.
Okay, thank you.
Professor, many times we get this individual loading as negative. How do we address those? What is the reason for that?
In fact, once the individual loading is negative, it means there could be two possibilities. That, for example, there are three items are positively loaded. One is the negatively. There could be a reverse coded question, number one. Number two, it could be a reverse causality or something. You know that there are the five questions. Four have the tendency of the convergence, and one is coming negative. So it means that there is a problem in this statement, that the statement is giving reflection of a negative sense, that for example, I have a high negative factor loading 0.70. The rest are the positively loaded. So it means that there could be a problem of the reverse coding. You can maybe recode the question in order to get the positive loading. So the problem, primarily this problem comes the reason of the convergence. There is no convergence in the items. So that's the problem. And this problem stems especially for the constructs, for the items which have the lesser reliability. Why? Because the question is being not understood properly by the respondents, number one. And this kind of problem is more apparent with the instruments or the construct which are just made. For example, I have just developed a new construct and I'm applying it. So that kind of problem is more apparent in that kind of construct, because those constructs are lesser trial and tested, and there could be some issues in the language or the statement of the questions. So there could be the multiple treatments of that kind of issue. One treatment is that obviously if the factor loading is negative and if it's less than it's between 0.3 and 0.4, so we remove that. But if the factor loading is negative and high, it means that coding that question reverse could result in the positive factor loading at the high end.
I think, yeah, it's high, negative and high.
Negative. So yeah, so you just recode the question, so you'll get the positive high. There could be, you have to just re-understand the statement, just read the statement again. Maybe you could find that your statement is differing from the rest of the four statements in the nature of response. So probably you reverse coding means that the response, which is 1, if you code it that 5 other way, for example, which is 1, you move to 5 and 5 is to 1, and so once you are reverse coding it, so obviously it would be aligned with your parameters.